Hello and welcome. We are Akram, Yasin, and Abdulrahman, final year computer science students at UMBB. Today, we're excited to introduce our graduation project titled Exam Absences Management System, or simply EAMS. Our project addresses a common and recurring issue at our university managing student absences during exams and efficiently organizing replacement exams without causing delays or scheduling conflicts. To keep our presentation clear and structured, we've divided it into five main sections, which we'll walk through one at a time. Let's begin with the current situation. At the moment, managing absences is entirely manual. Students must submit physical documents to justify their absence. This outdated process often results in unnecessary delays and added stress for both student and administrator handling the requests. Documents can be lost or mishandled, and since there's only one person managing everything, the process becomes slow and inefficient, especially during peak exam periods. Additionally, organizing replacement exams manually often leads to scheduling issues, whether it's room availability, teacher schedules, or student conflicts, making the process even more difficult. So, what's our solution? The main goal of EAMS is to digitize and streamline the entire process, making it easier for and more efficient for everyone involved. Students will be able to submit their absence justification online with just a few clicks. The system then automatically schedule replacement exams, carefully avoiding any time or availability conflicts. One of EAM's key features is real-time notifications, instantly keeping students, teachers, and staff informed as updates occur. We've also focused on building a system that is fast, dependable, and user-friendly, with simple and intuitive interface for all users. Now, I'll hand it over to Yasin, who will walk you through the next part.
Hello, I am Yasin, and I'm gonna present the modeling part. We begin with the system development phases. The first phase is problem analysis, where we define the core issue in this case, the need for an organized and fair way to handle exam rescheduling. Next is requirements gathering, where we collect input from users like students, administrators, and teachers to understand what features the system must support. Then we come to the UML modeling, where we translate these requirements into visual diagrams to clarify user roles and system functionalities. Finally, in the system design phase, we define how the system will work, including its architecture, main components, and how they interact. With the design in place, we move to the use case diagrams, which show the main actions each user can perform. We start with the admin use case diagram. Admins log into the system, submit and edit exam schedules, and review student justifications. Based on the submission, they can approve or reject requests, managing the exam process fairly and efficiently. Next is the student use case diagram. Students begin by logging in, selecting the model they missed, and submitting justification. This action triggers the admin's review and starts the overall workflow. Finally, the teacher use case diagram. It shows how instructors are involved. Teachers can view affected students, suggest changes to proposed exam times, and reject requests when needed. The role ensures scheduling fits academic requirements and availability. To understand how these roles or to understand how these roles interact over time, we turn to the activity diagram. The process begins when a student submits a justification. The system checks the document. If it's invalid or expired, it's automatically rejected. If valid, the system tries to auto approve or reject the request based on predefined rules. If the system can't decide, the case is forwarded to the admin for manual review. Teachers may also be consulted if schedule adjustments are needed. Once a final decision is made, the student is notified, completing the process. The activity diagram clearly shows how users and system logic work together to handle submissions efficiently and fairly.
Hello, my name is Ghullab Abdurrahman, and I will be presenting the implementation aspect of our project. Our system is built using several modern and powerful technologies. I will highlight the most significant one. For development, we have used VS Code, a lightweight and future-rich code editor that offers excellent support for JavaScript and TypeScript. The core programming language of our project is TypeScript, which extends JavaScript by adding type enforcement. And to run TypeScript directly with a high performance, we have used Bun, a modern JavaScript runtime that is significantly faster than the traditional Node.js environment. Our application is built with Next.js, a powerful React-based framework that allows us to develop both of front-end and back-end features within a single unified project. For styling, we chose Tailwind CSS, utility-first CSS framework that provides a wide range of predefined classes. These technologies collectively enable us to develop a robust, maintainable, and high-performance full-stack web application. To conclude, we have further perspectives to enhance our system. We propose the following improvements: real-time notifications using WebSockets to keep users instantly informed. Interactive calendar integration for more intuitive scheduling experience. Machine learning document analysis to detect fake or tempered justifications and ensure they come from trusted sources. Automatic refusal of justifications for students confirmed to be present at the original exam. An appeal system to handle false rejections and maintain fairness. Now I will be demonstrating the core features of EAMS through a live walkthrough. I will begin with the student interface. Here's the login page. I will enter my username and password to log in. Once authenticated, the student lands on their dashboard, where they can see a list of their replacement exam submissions. Each submission is displayed with its current status, such as approved, refused, pending processing, and pending manual review. Now I create a new submission. I open the modules list. We can select one or more modules. As we see here, there's a few disabled modules, and that because 73 hours have already passed. I would go with AI to test with. Here we have three justification files to test with. There's a valid justification, an old one, and a random document. Here we can drag and drop the file or simply browse to the file path. Select the file and we wait until it gets uploaded. Now after submitting, we wait for the system until it takes its decision. Now the submission has been automatically approved and we have received a notification as well. Now we will see the cases when we submit with the old file and with the random file.
And lastly, we would like to express our sincere gratitude to our supervisor, Dr. Sabo, for their guidance and support throughout this project. Thanks also to the faculty of the Department of Computer Science at UMBB for providing a strong academic foundation. Finally, a heartfelt thanks to our families and friends for their constant encouragement and support.